All right, let's take a look here out of 10.2. So 10.2 had two options here. We're going to do a test statistic like in this first example that we have, and then we're going to do a confidence interval in the second one. All right, so the first one that we're going to look at here, we're going to be looking at our test statistic. So keep your formula sheet handy. I'm going to come back over here to this formula sheet. If you're talking about a proportion, your test statistic is going to be this formula. If you're talking about a mean, your test statistic is going to be that formula. 10.2, 10.3. Now, with that being said, I am going to solve these the long way. In essence, you can't see it, but I'm air quoting the long way using the test statistic. If you want to use StatCrunch to come up with these values, do it, right? There are videos embedded in your notes, and go through those, watch how to do StatCrunch. I'm going to do this with the formulas just so that you have the background way to do it, but you don't have to do that. If you want to use StatCrunch, then by all means, please go use StatCrunch. That's good. Okay. So in a clinical trial, 23 out of 878 patients taking a prescription drug daily complained of flu-like symptoms. Suppose it is known that 2.2% of the patients taking competing drugs complain of flu-like symptoms. Is there sufficient evidence to conclude that more than 2.2% of the drug users experience flu-like symptoms with a 0.01 level of significance? All of this helps. So in your problems, they're not going to say, take this only from section 10.2. You're going to have to recognize which test statistic that you're going to go with. I have a percent here. That's a tip-off for me, right? When that percent, and whenever I have something out of something, then I know that is going to be my tip-off that I am using P. That is my proportion. And we'll change it to a decimal. All right, so all of this information is going to be helpful. So if I'm looking at my null hypothesis, it is known, so my proportion is equal to 0.022. My alternative hypothesis, what we're trying to figure out, still a proportion, but it says more than. Because this says more than, I know it's going to be greater than 0.022, right? So that's what we're looking at. All right. So we want to come up with our test statistic so we can get our p-value. Because remember, and I'm just going to put a little note up here, just as a side note, remember if the p-value is less than your level of significance, then you remember we have to reject it. All right, that is telling me that I have sufficient evidence in order to change my mind, right? We're back to that kind of thing in order to reject it. So the first thing we need is our test statistic. So we go to our handy dandy formula sheet. I know that I'm talking about this P. I've got these P values in here. So because I have these P values, I am looking at the Z scores. Proportions, Z scores. Mean, T scores, right? Remember that? Okay. So if I have a, oops, that's not helpful, test statistic, then I'm going to write my formula down here so that I can fill in and we can see what we all need. So I already have this P naught over here. That's what I start with. That's my initial. My P hat, however, is something that I still need to get. So that's going to be 23 out of 878. I'm going to go ahead and round that to four decimal places. Now here's the other beauty of video, you guys. I'm just going to keep on going through here because I've already done this so I know my values. Pause it. Try that, see if you get the same values. So pause the video, that's the beauty of video, right? Pause the video and make sure you're getting these same values that I am. If you're not, then email me and I will help you. Okay, plug in everything you know. 0.0262 minus 0.022, because that's my P naught. That's the information I'm given. And then the square root, 0.022, 1 minus 0.022, divided by 878. When you chug that out, so pause the video right now, chug that on your calculator, then start it up again, and you'll see that you get a 0.848. Now, this is your z-score. You're going to the chart. On the chart, it's only to 2 decimal places. So I am looking at 0.85 on that chart. So let me come over here and look up 0.85. So 0.801, 2, 3, 4, 5. I'm going to squeeze this in. See how this is 0.05 in my column? And then 0.8 comes across here, and that's how I get the 0.8023. All right. So when I'm looking at my values, this says more than. So this tells me I have a right-tailed test. When you have that, I'm going to bring it up here. Just like any of the other ones that we've done with our z-score and a right-tailed, I'm going to do 1 minus that 0.8023. So my actual p-value is 0.1977. So that is my p-value. Now remember, how we pull this off is my p-value has to be less than my level of significance in order to reject this. So make the comparison. Is 0.1977 less than 0.01? No. Because that is not less, my p-value is not less than my level of significance. Right there, right? My level of significance. That's where I got that 0.01 from. Then we do not reject. All right? I am not rejecting. I don't have enough evidence to change my mind. That's what's happening. What we started with, what is known, stays. That's what all of that means. What is known stays. Therefore, there is not sufficient evidence to conclude that more than 2.2% of users experience, learn how to spell, step 1, flu-like symptoms. You know my terrible handwriting, so that just is what it is. All right, there is not sufficient evidence. We are not rejecting what we're starting with. You're not giving me something new to change my mind. That's what's happening here. All right? Okay, so p-value. Plug that stuff for that test statistic in. Make sure you're getting that number. If you're not getting that number, then you need to email me and we need to figure out how to use your calculator.